This is a continuation of the transport layer video. So in the next section here, we're talking about TCP features. So we notice here the following services are provided by TCP. They establish a session, ensure reliable delivery, provides for same order delivery, and support flow control. So what do we mean by this establish a session? Well, TCP is a connection-oriented protocol, so it does make communication with the destination before it sends something. It does this during a three-way handshake, which we'll look at a little bit later on in this section. Ensures reliable delivery, so it makes sure that all the segments reach the destination, and it does this through acknowledgments. Provides for same order delivery. So sometimes when the packets or the segments are broken down into different pieces, they will be put in order and sequenced with a particular number. When they reach the destination, because they've all traveled in different paths to reach the destination, sometimes they may have to be reassembled to put back in the proper order once they reach the destination. And then flow control. With flow control, what we're really referring to here is the sender and the receiver will decide on how much data will be sent at one time to keep the destination device from becoming overwhelmed, or if you're familiar with the buffers, to keep the buffers from overflowing. Now, TCP is a stateful protocol. That means it keeps track of the state of the communication session that's running. So to track the state of that, it records information that it has used through acknowledgments. It also begins a session with a session establishment and then ends with a termination of that session. TCP segments are 20 bytes. So they do have a little more overhead than UDP because they have a little bit more information. So you see they're 20 bytes. You have a source and destination port, sequence number, the acknowledgement number, header links. You have some control information, the checksum information. If you'll remember from earlier on in the curriculum where we talked about your checksum or your CRC value. Okay, so that is that polynomial calculation that occurs before data is exited from an interface, and then it's done again once it reaches the destination. So it comes in on the incoming interface and it performs the same calculation. If it comes up with the same number that the sender used, it assumes the information was sent correctly. So you have some windowing and a couple of other fields. You see the table here that identifies each one of these. Okay, so you want to make sure you review those. Your applications that use TCP. So we have HTTP. So we use that for web pages, right? Your FTP will be used for file transfer. SMTP, that's used for sending mail. And then SSH is another example. So SSH is like a more secure version of Telnet. With UDP, it is a little different. It's considered a best effort protocol. So it's referred to as a lightweight protocol. It doesn't provide TCP reliability and flow control. It's more of a simple protocol. So with UDP, anything that was lost during transmission is not resent. It also doesn't set up a session establishment. So it really just sends the data and hope that it gets there. But it doesn't notify the sender that it did not reach the destination. So again, this would be great for streaming because you wouldn't want the buffering that's there. You want to know that an email was sent correctly or sent to the right person. but it's not really necessary to know about every single thing that might happen during a voice over IP phone call or if you're watching a movie, because typically those movie clips will be flashing so fast that you may not recognize it unless it's just a huge buffering issue. So UDP is great for streaming data. It's considered a stateless protocol, which means that neither the client nor the server is going to track the state of that communication session. So if it does need reliability when you're using the UDP protocol, that would be handled by whatever application is using that. You can look at the header here and see that it's much smaller than your TCP header. You don't have all of the same information. Notice you're missing several of the fields that you did have in the TCP protocol. So if you're looking at the protocols that use UDP, again, these will be your streaming types of data, or anything that you don't necessarily need to have an acknowledgement for every single segment that was sent. So simple network management protocol, DNS, DHCP, TFTP, voice over IP, video conferencing, these would all use your UDP protocol. So I referred to port numbers earlier. Port numbers are used to track conversations. What do I mean by tracking the conversations? Again, if you're using email and you're using, say, a web client, or you're, using FTP, you want all of those conversations or those data streams to be kept separate. So you can still use the same IP address because data is still destined toward the IP address, but you have to be able to sort within the IP address. And that's where this term socket pairs comes in. So if you're looking at an address, a socket is used to identify the IP address and the port number. So in this case, you have 192.168.1.5.1099. That is the port number, or 192.168.1.7:80 would be the port number, so that would indicate web traffic. Okay. So an IP address and the port number are referred to as a socket, and here they had a sending and receiving, and they refer to those as a socket pair. Now, there are different ranges of numbers according to the port group they're assigned to. So well-known port numbers are going to be assigned in this range from 0 to 1023. So I mentioned, say, Telnet, for example, which would use port number 23. It falls within this range. So these are all protocols that are well known. This would be worldwide, okay, so this is not just US. So it would signify a particular protocol. Registered ports, these are more individual type applications. Okay. So an example that's given here is Cisco. It uses the registered port number 1812 for the Radius server for authentication. Private or dynamic ports, these are usually by a client's operating system, and they would fall within this range that you see, the 49,152 to 65,536. So typically they're generated dynamically by the client's application. So they would be added at the end of the IP address. Some of the well-known port numbers that I would recommend memorizing, especially if you are a networking student, and if you're going to take additional CCNA courses, you'll want to know these port numbers because you will have to identify applications based on the port number. And if you're using something like Wireshark and examining the information, and something is listed in a port number, you would automatically know what particular application that was using that particular device. Also know whether the application is using the TCP or UDP protocol as well. So you see all of these listed here. Again, I would memorize this list. You also need it for your CCNA exam, and it will be very useful when you start configuring access control list. Now, sometimes you'll want to enter the netstat command. The netstat command can be issued to indicate the protocols that are being used, the addresses and port numbers. So by default, this command will attempt to resolve IP addresses to domain names and port numbers to their well-known applications. If you're looking at the TCP server process, okay, we've talked a little bit about how TCP works, but this kind of just shows you the actual process. So client 1 is requesting web services and client 2 is requesting email service at the same time. So for the HTTP request from client 1, the source port was automatically generated from those dynamic ports that we looked at earlier, but the destination port is 80, which means it's requesting web traffic. So here, this is using SMTP, which uses port 25, so that's why that would be listed in the destination port, and then the source port was automatically generated because that's coming from a client. Both of those are heading towards the server, so that's how they're keeping all of that straight, and that would be according to the port numbers that are being used by each of those clients. And that's highlighted here. The destination or the dynamic port number is listed as a source port here. The server responds to the client using the source port from the packet that it received. So now, excuse me, now the source port becomes the destination port as it leaves the server going towards the client. And then it's able to respond back to the client. Now I mentioned the three-way handshake earlier. So this is where we'll talk about the three-way handshake if you're looking at TCP connection establishment. So here you have a client request communication with the server. So it sends the send request and it's received. Then B sends a send request and an acknowledgement response back to A. And then A responds with an acknowledgement for the send request sent by B. So this is the three-way handshake where both sides decide that they're going to send information. The same thing happens during the session termination. So everything is very clear within TCP. Both sides know exactly what will be happening. So computer A decides that it is done communicating with computer B. It sends a fin bit, fin for finish. It's received by B. B will send an acknowledgement, and then B will send a fin bit to A, and A will acknowledge that. Okay, so both sides send their communication, and then they wait for an acknowledgement. So here's the functions spelled out or written out on the three-way handshake. It's important to understand these. So it establishes the destination device is present on the network verifies that it has an active service and it's accepting requests, and then informs the destination that the source client intends to establish a communication on that port number. There are some control bits, or 6 bits in the control bits field of the TCP segment. And a flag is a bit that is set to either on or off. And you see those listed here. The urgent pointer, acknowledgement, the push function, reset the connection, synchronization bits, or fin bits. You have a video on the TCP three-way handshake, so I would definitely recommend watching the video. Now also with TCP, you have guaranteed and ordered delivery. That's one of the great things about TCP. Again, its whole purpose is to make sure that data is received at the destination. Here we're looking at data being divided into segments and numbered. So it's segments 1 through 6. Well, if that data takes different routes to get to the destination, it may arrive out of order. So what TCP does is make sure it's put back into order when it's received at the destination. Also, with TCP, it does provide acknowledgments. And it usually does this in the form of what's called an expectational acknowledgement. So with this, computer A is sending data to computer B, so it's in segment 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, so all 10 segments. Well, there was an issue here with segment 3, so computer B responds with an ACK3. Acknowledgement 3 is what it needs to receive. And then you do have some duplicate segments, but all of those are resent. And then notice it has an ACK11. That means it's ready for 11. So expectational acknowledgement, I expect number 11 next. So we have another example of the data being sent and then acknowledgements. Also, window size is done too. So during that three-way handshake, both sides determine how much data will be sent at one time. So it says they're going to send a window of 10,000, send the first sequence number, the second sequence number. So 2920 was sent, and acknowledgement was sent for 2921 because of the expectational acknowledgement that I was referring to earlier. And both sides also determine the maximum size. Again, this is so that the other end is not overflowed, so the buffer doesn't overflow. So if it's sent too quickly, data will be missed. So here we're looking at the amount of data that's being sent and how that is all determined. So it's very common for 1460 bytes to be sent when using IPv4, but the host actually determines that value by subtracting the IP and TCP headers from the Ethernet's maximum transmission unit. So by default, Ethernet maximum transmission unit is 1500 bytes. So you subtract the IPv4 header of the 20 bytes and the TCP header of 20 bytes. The default size becomes 1460, as shown in that figure there. I don't believe you'll have to calculate that, but I thought I'd go over it just because it was right here. With your congestion control, acknowledgement is very helpful. So in this example, one segment is sent, then there was an issue with 2 and 3 and 4. So the recipient sends an acknowledgement for segment 2, again, the expectational acknowledgement. This is where you see this here. Acknowledgement numbers are for the next expected byte and not for a segment. So there's a lot of information about TCP. It's a little bit more involved. UDP, it has way less overhead, but it's not as reliable as TCP. So it does not establish a connection before it sends. It does not do the three-way handshake. It's considered connectionless and unreliable. So if you're looking at the datagrams sent, even if they're out of order, they're not put back in order and they're not resent. But again, it's usually not a huge issue if you're looking at a video and there's one small blip there, or whatever you want to call it, one small section, you probably wouldn't even notice it. Okay. It has to be quite a few errors really for you to notice visually or for you to hear if you're using voice over IP. But you would notice the buffering if there was a bunch of acknowledgements in the middle of a video. So it operates similar to TCP. That's going to use the port numbers, and these are port numbers specifically associated with the UDP applications. So in this case, it's going to be done the same way, where the dynamic port number is used by the clients, and you have specific port numbers used for destination, and then they'll use the reverse when they're communicating back to the client. So quickly, as you go through here, client requests UDP server to use well-known port numbers at the destination port. Random port numbers is the source port. Then the server responds using the source port from the request packet as the destination port, and the server responds to the UDP client using the well-known port numbers. So that sums up the chapter or module on TCP and UDP. So in summary, remember that you have two protocols at your transport layer, your TCP protocol and your UDP protocol. TCP is connection oriented, so it provides some acknowledgement and reliability, whereas UDP does not. Okay. So UDP is best effort delivery system. With TCP, it has more overhead and the header itself is larger than UDP because UDP has less overhead because it's not providing the acknowledgement and the reliability and the flow control and some of the other information that's provided within TCP. I would make sure you know those port numbers. Okay. So the port, specifically the port numbers for each particular protocol. So that would be important as you progress throughout your CCNA studies. I would make sure you work on the module quiz at the end because that will help to make sure that you have a good understanding of what you learned. And then you should be very confident in knowing the transport layer.